This is a total production. Hello, Chem Minions. Alright, so this is going to be our second practice video for Chapter 4, looking at chirality. And so now we're actually going to look at, if I give you a chiral center, how do we need to go about figuring out the R and S configuration stuff? Alright, so let's start. This one's a little complicated, so I'm actually going to hold off on that one. I'm going to jump to this one real quick, and then I'll come back to it. So for this one, all right, we're indicating that carbon right there. Now, three things are shown, so we know there's a fourth thing, and we know it's got to be a wedge hydrogen. All right, now the fact that it's wedge is going to be important here in a minute. Now, first rule is we need to look and assign priority based off the atom that's connected to that carbon. So this has a carbon connected and a carbon connected. So those are the same. So we can't really make a determination about that. But if we compare these carbons to the hydrogen and to the nitrogen, well, we know that nitrogen, if we look on the periodic table, if you don't know, but if you look on the periodic table, nitrogen has a larger atomic number than carbon or hydrogen. So it's first priority. And then that also tells us that hydrogen has the smallest atomic number. So it is our fourth priority group. So we really need to figure out between the methyl and the ethyl which one gets priority. And to do that, you need to look at branching. So if I were to identify this as carbon alpha, this is just an identifier. Okay, that's it. Label that as carbon alpha. Label this as carbon beta. Well, for carbon alpha, besides the bond that's shown, right, to the chiral center, what are the other three things that are there? It's going to be hydrogen, 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 right? If we look at carbon beta, what else is there besides this bond to the chiral carbon? Well, there's one bond shown with carbon, and there's two invisible ones with hydrogen. So when you look at these two carbons, you say, all right, well, what is the largest atomic number that's attached to it? Well, for this one, they're all hydrogen. But for beta, you have hydrogen versus carbon. So carbon has the higher mass atomic number. So with that, that means that carbon beta has a higher priority than carbon alpha. So the next in priority would have been 2. And then here it's going to be 3. All right. Now, what do? We make a circle. We go from 1 to 2 to 3 back to 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So we're going to do this 1, 2, 3, 1 stuff. And you notice that the circle that I'm forming is going in a clockwise fashion, or what I like to say, overhead right. So it looks like it's R. It looks R, right? If the circle goes clockwise, overhead right, it looks R. But we need to make sure. And how do we do that? We look at our fourth priority group. In this case, it's hydrogen. But in our fourth priority group instance here with hydrogen, it's in the front. It's got a wedge, so it's poking out at the front. So that means it's in the opposite location of where we want it. We actually want it with the dash, not with the wedge. So it means we're looking at it backwards. That's all that means. So since it looks R from looking at it backwards, well, what's the opposite of R? S. So this chiral center is S. Looks R, but backwards. But it's backwards. Okay, so that means it's S. All right. Now, we can kind of look at this one then. When we look at this, we have an invisible hydrogen that's a dash. Now, in this case, that dashed hydrogen is exactly where we want it. So that's great news. All right, so whatever it looks like, that's what it is. But when we look, we have a carbon, and a carbon. So if I label this as carbon 1, no, I don't want to do that. If I label this as carbon alpha, carbon beta, and carbon gamma, I need to look at what's the bonding that's going on with these. So if I look at carbon alpha, all right, what does it have? So besides this bond, it's got a double bond and it's got a hydrogen here. So that double bond, right, I write that as 2 single bonds with this carbon, right? So I would write C, C, and then I got a H, okay? Now, when I look at carbon gamma down here, right, it's got 2 hydrogens and a carbon. So hydrogen, hydrogen, carbon. And then if I look at carbon beta, what does it got? It's got 2 carbons and a hydrogen also. So alpha and beta look the same right now, but we're gonna have to actually elaborate on those in a minute. But see, 2 carbons and a hydrogen, 2 carbons and a hydrogen. But if you look at carbon gamma, it only has 1 carbon, so it lost, right? So what does that mean? That means if we know our 4th priority group, that means that our carbon gamma is our next lowest, so it's 3. So now I got to figure out between alpha and beta which one would be first priority, which one would be second. So when I look at carbon alpha here, let's elaborate on what these carbons look like. So for instance, this carbon right here, right, is bound to is bound back to that carbon, but it's also bound to a second carbon here. Okay? And then it's got a hydrogen. So it has a carbon-carbon hydrogen. So this guy is that guy. I'm circling it for you. Now, when I look at, say, this carbon here, it has a carbon and it has 2 hydrogens. Sorry, I'm having to kind of write through that. So when you look, so I'm going to put a box around it so you can see what I'm comparing. All right, so when I look at that, what have I got? I've got 2 carbons and a hydrogen, or 1 carbon and 2 hydrogens. So if I take the largest mass number first, or atomic number first, they would cancel. So now what's the next biggest? Because all this is canceled already. So now I'm comparing a carbon to a hydrogen. So that means alpha is the higher priority. So it's priority number 1, and then this double bond over here is priority number 2. So when I look at this going 1 to 2 to 3, right, I'm going 1, 2, 3. It looks like, yet again, I'm going overhead right or clockwise. And so it looks R, right? And when I look, my 4th priority group is a dash. So it looks R, and it is, in fact, R, right? Because my 4th group is the dash where I want it. All right, next up, we've got CH2OH. This is a CH2CH3, and then that's a whole bunch of stuff. All right. So we've got our 4th group, hydrogen. That's just automatically known to be 4 if it's ever present. Okay, it's the smallest thing on the periodic table. So now we have to figure out 1, 2, and 3. So when we look at carbon alpha, beta, and gamma on this one, so carbon alpha has 1, 2, 3 bonds with carbon. So I need to write 3 single bonds with that guy. Carbon beta has 2 hydrogens and an oxygen, and then carbon gamma here has 1 carbon and 2 hydrogens. Alright, so now what do? When you look at this branching, you take the highest atomic number atom first. So when we look at carbon alpha, we're comparing carbon. If we look at carbon beta, we're comparing oxygen. And if we look at carbon gamma, we're comparing carbon. So guess what? The CH2OH actually is first priority. All right. A lot of you guys are going to get into the habit of just saying, oh, that's a really big ring, so that's automatically got to be the highest priority group. No, it's the bonding. We look at how it bonds, what it bonds with. So that's 1. All right. And so that means that now we still have to compare alpha and gamma. So in this comparison, so these are gone, right? So now we compare the next biggest thing. We got carbon, we got hydrogen. And so that means alpha wins. So the next alpha is now our 2nd priority group, and our gamma is our 3rd. So now when we look, we've got 1 to 2, 2 to 3, back to 1. So it's going counterclockwise or overhead left. So that means it looks S. Now we need to check, is it in fact S? You look at that 4th priority group, it's a dash, so it is exactly what it looks like. So that is an S. All right. Next up, we've got this chiral center that's got a bromine, a carbon, and we've got a wedged hydrogen. All right, so based off what we have, carbons, bromines, and hydrogen, the larger atomic number is bromine, so that's 1. The smallest is hydrogen, so that's 4. So we really have to look at these 2 carbons. What does this carbon have on it? So I'm going to label that one alpha, label that one beta. So here, carbon alpha has 2 hydrogens and a carbon. So 2 hydrogens and a carbon. Carbon beta has what? It's double bound to an oxygen. So I'd write that as 2 oxygens, and then it's got 1 hydrogen. So what do? You compare, oh, sorry. So what do when you look at carbon alpha and beta? You compare the larger atomic number thing. All right, so the largest on this one would be carbon. The largest on this one would be oxygen. So based off that, carbon beta wins the priority match between these two. So the next highest priority is 2. So the carbon beta is 2, carbon alpha is 3. So what do? We make a circle, go from 1 to 2, 2 to 3, 3 back to 1. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. You ignore 4 in your circle. Okay, so now that we're doing our 1, 2, 3 business, it looks like it's going overhead left or S. So it looks S. Now, is it S? What do? We check our fourth priority group, hydrogen. It's a wedge. It's the exact opposite place we want it. So it looks S, but it's in fact the opposite of S, which means it is an R. Okay. All right, next up, what do we got? Ooh, now we've got an oxygen, a carbon, and then we have a dashed hydrogen. So I can go ahead and tell you, right? Oxygens are the higher atomic number, then carbon, then hydrogen. So I know 4 and I know 3, all right? Because it's really between the oxygens now. So when we look at oxygen alpha and oxygen beta, what do they have? Well, oxygen alpha just has 1 hydrogen. Oxygen beta has 1 carbon. So which one wins? The carbon one, right? So that means our highest priority group is here, and our next one is there. So when we do our 1, 2, 3 business, 1, 2, 3, 1, 2, 3, 1, 2, 3, it looks like it is going counterclockwise or overhead left. So that means it looks S. All right, is it S? Is our fourth group dashed? It is. So it looks S and it is S. So there's the answer. All right, and I'm trying to keep these answers right at the end of these arrows so that you can kind of keep up with it, because I know there's a lot going on this paper. All right, next up, oh no, we got a whole bunch of carbon connections. So I'm going to go ahead and show my fourth invisible hydrogen. It's a wedge. Okay, so I know it's 4, and it's the opposite of where I want it. So whatever it looks like, it's the opposite. Now, so let's look. We have a CH3, we have a CH2, CH3, we have a CH2, CH2, CH3. The thing with chains is, since there's no double bonds and there's nothing else there, these are easy. The longer the chain, the higher the priority. So this is priority number 1, this is priority number 2, and this is priority number 3. You can only do this if they're all alkyl chains, okay? If there's any pi bonds, and if there's anything other than carbon and hydrogen, then you can't just do it this easily, okay? But when it's just alkyl chains, it's that easy. So let's see. And you can do the branching to figure that out. So practice it on your own and see if you can figure that out. But anyway, so you've got 1 to 2, 2 to 3, 3 back to 1. So it's going overhead right. So it looks R. Is it R? No. Our fourth group is the opposite of where we want it. So, but it's the opposite. So opposite fourth group. So that means it looks R, but it is in fact S. Wow. I've had 2 R's and 4 S's. I seem to have favored S's with these. I'm going to be honest, I just kind of made these up. I didn't even pay attention. All right, next up, what do we got? We've got, oh, this one has 2. Okay. Wait, those are the same. That and that are the same. So I only have to do this once. Okay. So I tell you what. I won't do this chiral center on this molecule, but I'll do it here. So I won't do that one. All right, so let's look at what we have in terms of priority. So we've got a wedged hydrogen, a dashed chlorine, and then we got carbons and carbons. So of these 4 things attached, we automatically know 1 and we automatically know 4. So let's kind of break down what we have for carbon alpha and what we have for carbon beta. So for carbon alpha, what has it got? It's got a double bonded carbon, and it also has a hydrogen here. So I need to draw 1 hydrogen and then 2 separate carbons. For carbon beta, let me see if I can move this up a little bit. For carbon beta, what do we got? We've got 2 hydrogens and a carbon. So 2 hydrogens and a carbon. So hopefully, now that you see the 3 things attached, we can see, oh, well, the biggest thing is carbon, so those cancel. The next biggest thing on this one's carbon. The next biggest on that is hydrogen. So carbon alpha definitely won here. So the next priority is 2. So alpha would be 2, beta would be 3. So if we follow our 1 to 2 to 3 back to 1, it's going overhead left. So it looks S. All right, it looks S, but our fourth group is the opposite. So, but it's the opposite because of that fourth group. So that means it is R. All right. Now, we can do the same thing with looking at the chiral center here. Let's see. We have yet again a chlorine and a hydrogen. A chlorine, hydrogen, carbon, carbon. We know what the deal is, y'all. Come on. So we know that this is 1. We know that this is 4. But now when we look at, I'm going to make that alpha and make that beta. If we look at carbon alpha, what does it have connected? It has 2 hydrogens and a carbon. So carbon alpha has a hydrogen and 2 carbons. And I'm going to do carbon beta way down here. Carbon beta has, no, it was 2 hydrogens and a carbon, sorry, for both. So that means the first layer of connections cancel. So that means what we really need to do is look at this carbon and look at that carbon. So what do we have on those carbons? So for carbon alpha, this carbon, so that carbon is this one right here. So that's the dot. I'm going to put the dot there so we can kind of see it. So it has a chlorine, a hydrogen, and a carbon. Okay. And then I'll put a dot on this one for carbon beta. So this carbon has a bromine and a double bonded carbon. So that would be 1 bromine and 2 carbons. So I had to go to the second layer to get this guy figured out. All right. So when I look, I compare the largest atomic number. That's bromine, that's chlorine. Which one wins? Bromine, bruh. So that means I'm going to have carbon beta. Yeah, carbon beta had the bromine. So carbon beta is second priority, and then carbon alpha is third priority. And now we check it. 1 to 2, 2 to 3, back to 1. So it's going clockwise. It's going clockwise or overhead right. So that means it looks R. Is it in fact R? Is the hydrogen, the fourth group, dashed? And it is. So it is exactly what it looks like. So that's an R. Okay. All right. So hopefully this gives you quite a bit of practice so that you can practice this on your own. I know there's a lot to it, but you kind of have to get the gist of things. All right. Adios and stay weird.